Visit Chandra's beautiful universe. James Webb Space Telescope and Chandra images. In the summer of 2022, NASA's James Webb Space Telescope released images from some of its first observations. Almost instantaneously, these stunning images landed everywhere, from the front pages of news outlets to larger-than-life displays in Times Square. Webb, however, will not pursue its exploration of the universe on its own. It is designed to work in concert with NASA's many other telescopes, as well as facilities both in space and on the ground. These new versions of the Webb images combine its infrared data with X-rays collected by NASA's Chandra X-ray Observatory. They underscore how the power of any of these telescopes is only enhanced when joined with others. Let's take a look at each. Webb brilliantly shows how the galaxy cluster SMACS J0723, located about 4.2 billion light-years away, contains hundreds of individual galaxies. Galaxy clusters, however, contain far more than their galaxies alone. As some of the largest structures in the universe, they are filled with vast reservoirs of superheated gas that is seen only in X-ray light. The Chandra data reveal gas with temperatures of tens of millions of degrees, possessing a total mass of about 100 trillion times that of the Sun, several times higher than the mass of all the galaxies in the cluster. Invisible dark matter makes up an even larger fraction of the total mass in the cluster. The four galaxies within Stephan's quintet are undergoing an intricate dance choreographed by gravity. The fifth galaxy is an interloping galaxy at a different distance. The Webb image of this object features never-seen-before details of the results of these interactions, including sweeping tails of gas and bursts of star formation. The Chandra data of this system has uncovered a shockwave that heats gas to tens of millions of degrees, as one of the galaxies passes through the others at speeds of around 2 million miles per hour. This new composite also includes data from NASA's now-retired Spitzer Space Telescope. Chandra's data of the cosmic cliffs reveal over a dozen individual X-ray sources. These are mostly stars located in the outer region of a star cluster in the Carina Nebula, with ages between 1 and 2 million years old, which is very young in stellar terms. Young stars are much brighter in X-rays than old stars, making X-ray studies an ideal way to distinguish stars in the Carina Nebula from the many stars of different ages from our Milky Way galaxy along our line of sight to the nebula. The diffuse X-ray emission in the top half of the image likely comes from hot gas from the three hottest, most massive stars located in the star cluster outside the field of view of the Webb image. Finally, the Cartwheel galaxy gets its shape from a collision with another smaller galaxy, located outside the field of this image, about 100 million years ago. When this smaller galaxy punched through the Cartwheel, it triggered star formation that appears around an outer ring and elsewhere throughout the galaxy. X-rays seen by Chandra come from superheated gas, individual exploded stars, and neutron stars and black holes pulling material from companion stars. Webb's infrared view shows the Cartwheel galaxy plus two smaller companion galaxies, not part of the collision, against a backdrop of many more distant galactic cousins.